Good afternoon, everyone. My name is Edoardo de Santis. I'm a PhD student from Sapienza University of Rome, and I'm presenting this work, actor-based framework for interoperable BIM data management, which aims to address the challenges of interoperability in the process, building process management. It all starts from the evidence of the complexity of the design process, which is led by the fragmentation of the industry, the complexities of the projects, and the multiple software involved in the process that leads to problems in coordination and communication of project-related data and information. Today, file exchange, data exchange is based on in different ways, from the traditional file handover model, where entire building models are exchanged in specific moments of the process, to more advanced solutions such as information containers or common data environment. But usually in all of these cases, the exchange happens in specific moments of the project, and it's bulk transfer of an entire new model. From the architecture point of view, there are centralized and decentralized solutions, where centralized ones have the benefit of better integration of different tools, but they can lead to bottleneck and single point of failure, while decentralized one can address better the problems from this AEC industry, but they need more standardized protocols to keep all together. The main core of this research is the integration of an actor-based model, where actors are single digital entities that are independent and communicate via messages between them. And in this case, each actor is representing a single point, a single building element in the BIM model, and every element is exchanging information when a change is made, and they keep synchronizing themselves based on the other actions. So the main objective is to address the fragmented and inconsistent exchange of management of data through an actor-based model and the integration of the linked data to make data more structured and machine-readable for the actors, and to increase interoperability. Specifically, the objective is to reduce manual export, to avoid misaligned updates, moving to some autonomous digital actors that are managing and synchronizing this data, avoiding duplication of models, and also moving from BIM models managed as monolithic blocks to more per element management of data. And this is the system architecture overview, and it's composed of two main parts, one on the user's machine and one shared on the server. So the first part is the BIM software, which contains the BIM elements, and each one has a unique ID. And near to the BIM software, we have the API connection, so a plugin that is monitoring as is working as an interface to facilitate data export from the BIM model to the rest of the system. And then we have a local connector that is mapping the BIM data to the actor representation that are shared on the server. And this local connector can act as an interface between multiple BIM software that can be installed on the user machine. And on the server, we have the main core of this research. So the server application contains an actor system with an actor for each building element, which is related to the BIM model with the unique ID. And data from these actors are stored in the storage part, so a graph-based solution where data is structured with industry ontologies. And this is a sequence diagram from the tests that we did in a controlled environment on a small BIM model. This is the creation of a model element. So when the model element is created, the data from this element is packaged and sent to the local connector that maps these parameters to the structure of the actors. And the actor system creates these actors and set up their values that are then uploaded on the storage part. So the main contributions are the decentralized solution of BIM data through an actor-based framework with the integration of linked data to make it rich data integrations and to align with ontologies. And also this fine-grained control over building elements, which aligns also with ongoing industry shifts such as IFC5. And there are still some challenges, for example, from the maintenance point of view, where mappings and ontologies keeps evolving, so there is a need to keep up with these updates. And also from the granularity of control point of view, to decide what's the best solution to map elements to actors. And for future work, some actors could be specifically dedicated for data validation, so to ensure that data is compliant with industry standards or some other project requirements, or even the integration of AI to enhance the capabilities of decisions that at the moment are based on previous coded logic inside the actor.